All right. Hello, UKNOF. My name is Melchior Aelmans. I work with Juniper Networks as a consulting engineer. And one of my, let's say, interests is in data center routing and in IP fabrics. So today I wanted to introduce you to a new and novel routing protocol named routing in FAT-trees. You might have heard about it a couple of times already because it's well, I think initial work started around 3 years ago, but it's almost there. Production. There's multiple implementations, and so let's talk about that. Small agenda. First, let's touch on what is actually happening in the data center and in IP Fabric. So we'll draw a little bit of the big picture. We'll talk about some of the drivers. Why do we actually need a new routing protocol in the data center? So we'll talk about some of the requirements as well, and then we'll dive into Rift. What is it? We'll discuss the basic concept. We'll talk about some of the advantages. It brings some new solutions that previous protocols couldn't do. And then we'll talk about the standard status. So it's still work in progress in IETF. We'll touch on that, and then we'll talk about the two implementations which are currently available. So let's start with the big picture. What is actually happening in the data center? We've come to a point where scale up isn't the answer anymore. Right, whether it's in BGP daemons, whether it's in chassis, and so especially in this case in IP fabrics, right? IP fabrics are used in lots of places, not only in the data center, but I also know, for example, of customers of ours who are using IP fabrics to build scale out routers. But in this case, there is a certain limit to what you can fit into one chassis. And now what if you want to scale beyond that, right? You can add a chassis and link those together, etc. But in the end, the answer is scale out. Lots of data center operators, folks who build IP fabrics, are these days looking into building these scalable fabrics using one new commodity pizza boxes, right? Whether it's a box from Juniper or any of the other vendors, preferably they need to interoperate with each other. We need flexibility and scalability. Lots of, let's say, new demands, driven a lot by, definitely by cloud providers, by hyperscalers. But there's also some challenges with current protocols we couldn't solve. For example, zero-touch provisioning, automatic deaggregation, etc. So let's first dive into two of the current protocols used in the data center. Right, the majority of operators uses obviously BGP or ISIS in underlay. So if you look at ISIS, or in other words, a link state protocol, it has some really nice features for IP fabric. If you compare ISIS to Rift, you see some of the elements reused, like for example topology elements that describe nodes, links, and prefixes. And ISIS floods those elements throughout the network. And the reason why ISIS is so popular, because it's really good at flooding. It's really fast. As soon as something happens, so a new prefix shows up, or you add a link or a node, it floods throughout the network, the newest version wins, and off you go. Also, each node within that network sees the whole topology and uses that information to compute reachability to everywhere. Makes conversion really fast. The downside, however, is that ISIS is so good in flooding that if you would use this in really large fabrics, and then I'm talking about 1,000+ nodes, for example, that flooding becomes an issue, right? You see on nodes having multiple copies, up to 20 or 30 copies of that same information because of the flooding. So yes, ISIS really good, but not maybe good enough. So lots of folks are using BGP, right? BGP is always the answer to everything. Some of the, let's say, specifics of BGP, as we all know, when advertising prefixes and through their neighbors, you gather metrics, you build up an AS path, and based on that AS path, you avoid, or you have loop prevention, for example. You can calculate the shortest path to your neighbor. And BGP is by far the best protocol if you want to do traffic engineering, right? Within these really large fabrics, there is demand for traffic engineering. So by far, BGP offers the best option to do so. And as we all know, it scales the internet. So BGP is pretty good in scaling. However, if you use BGP in an IP fabric, as described in RFC 7938, lots of you might have read it. If not, please go and read it. It's really interesting read. But you notice throughout reading that RFC that eBGP needs a lot of bandages and tweaking in order to make it suitable for the data center. Right, there is, again, I mentioned, for example, the really large fabrics, they run into issues with, for example, the number of ASs available. And yes, 65,000 ASs is a lot, but depending if you use private AS or eBGP or iBGP, there's lots of differences and other tweaks needed as well. For example, if you want to do multi-homing, etc. BGP also doesn't offer much options for zero-touch provisioning. There is work in IETF going on peer auto-discovery, for example, but it's not there yet. So then on the other hand, again, we have ISIS. As I said, it's really the best option if you're looking for convergence, right? It's by far the fastest protocol from a convergence perspective. But again, flooding is then an inherent problem as well. It's more or less received or seen as complicated, right? Everyone knows BGP, is probably very familiar with BGP, and the familiarity or at least level of knowledge in ISIS is a little bit lower. So that could be an issue as well. Obviously, ISIS wasn't really meant to also provide routing on the host solutions where you make your server part of the fabric in order to facilitate multi-homing, for example. So it's not really the answer yet.
Just to let you know, you have around 5 minutes left.
Okay, so what we've tried with Rift is to solve these issues, a lot of these issues, and add a few extra nice features. And I'll won't go through the whole slide, but let me quickly talk about the Rift concept, because this is probably the most interesting thing. Rift combines the best of both worlds. So if you look at this picture from the leaf perspective, it floods everything it knows northbound. So all routing information is flooded up to the spine and up to the super spine or the top of the fabric. On the other hand, it only advertises default routes southbound. In other words, the lower you go into the fabric, the quote, dumber the fabric can be. The good thing is that a leaf obviously only needs to know a few local routes and default routes northbound. So what that and what Rift offers, what other protocols cannot do, is automatic deaggregation. Right in this picture, you see that if the superspine B leaves, starts missing links towards A and B, you would black hole traffic that's sent to P1 from the left side of the fabric if B still advertises default route. So what Rift does automatically is it deaggregates the route towards P1 down into the fabric, so it attracts the traffic for P1. That is called positive disaggregation. But Rift also can do negative disaggregation, so it can advertise a route stating, do not use this route. So B could negatively disaggregate and advertise the route to P1 with the remark to not use it. That's really unique to Rift. And it offers options for unequal load balancing. So it takes into account all the, let's say, metrics in the whole fabric northbound of it. So it doesn't only look at the local links, but also further into the fabric. And with the probably 1 minute I have left, I want to quickly touch on these advantages. It's an open standard. It's really designed from the ground up. Yes, work in IETF is still going on, but that's about to become an RFC. And it has a lot of advantages. So if you are into IP fabric data center routing, I would definitely advise you to take a look at Rift. And feel free to reach out to me. All the slides are available to download. There's much more information to share here. And I'll leave there. If there's any questions for now, please let me know. Else find me on social or send me an email.
Thank you very much, Melchior. Leo, do we have any questions for Melchior's presentation?
We don't have any questions in the queue at the moment, but we might have a question coming in. Oh, here we do. We do have a question that has just come in from Blakely Willis, and I'll read that out once I've just noted that please answer the poll. Blakely asks, are there plans to add segment routing?
Excellent question. So Rift purely is a underlay protocol. So Rift builds your fabric, and whatever you run over your fabric isn't really up to Rift, but obviously there's situations where overlay and underlay need to interact. So yes, that's definitely something at least we're looking into. Same answer goes for example, support of EVPN VXLAN. Excellent question.
If anyone else has a question that they would like to ask themselves, then they can just nudge me in the Q&A and put their hands up, and I will unmute them so that they can ask verbally.
Yeah, or else feel free to reach out via email or social. I'm on Twitter, LinkedIn, etc. So find me there if you have any questions later on.
We don't have any more questions, and I think we are approaching the final moment. So I'm going to hand back for the next presentation. Thank you very much.
Welcome. Thank you.
Thank you, Leo. Thank you, Melchior.